So now we're going to look at average rate of change. Average rate of change is kind of like slope, isn't it? Rate of change is slope, how quickly something's changing over time or what have you, okay? Y equals mx plus b, that linear equation in that form. What part of that y equals mx plus b is the rate of change?
M.
M, right? So average rate of change, I always do that. Average rate of change is just another way to say the slope of a line, okay? Now, we're not only going to look at linear, right, but we're going to look at like quadratics and whatnot for an average rate of change, okay? So the average rate of change, it's an important concept. So by the way, if any of you ever went on to calculus from here, some of you won't, maybe a couple of you will, this thing that we're about to do is kind of like the fundamental core of calculus when we get there. So if you plan on going there, try and pay attention to this, okay? So we're going to quantify how fast a function changes, right, over a certain domain interval. Domain is what values?
Input and output.
Well, the domain is the input of the x's. The range would be the
Input of
output of
x.
y's. Okay?
And the range interval is the output of y.
Okay. So the average rate of change is just going to be the change in the output, okay, right, the y values, divided by the change in the input, the x values, like the difference in, so, and you see this here, this little triangle in front of f and an x, that's not a triangle, that's actually the Greek letter delta, okay? So that is delta, which also means difference. Okay? So if you see delta f, that means the difference in f values, and delta x is the difference in two x values. And mathematically, what operation allows us to find a difference? What operation? Adding, subtracting.
Division.
No, difference. Like, what's the difference between the number 7 and 9? What do?
You subtract.
Right, so subtraction gives us difference, right? And that's how you find a change in something. So we'd have y2 minus y1 divided by the difference in x's, x2 minus x1, right? So you'll have a function, and they'll ask for the rate of change between two x values, some interval, right? And you'll have to find the y's that go with those two x's, okay, and subtract them, by plugging it in. So in exercise 1, here's two functions. We got f of x equals 5x minus 7, and g of x is 2x squared plus 1. Which one of those is linear?
The 5x.
The f of x. And the other one is quadratic. The highest exponent is 2. So that's a curve, right? You guys remember this 2x squared plus 1, right? It's a parabola. Does it have a constant rate of change?
Yes.
No, it doesn't.
No, it doesn't.
It does not. It does not. The rate of change is always changing for one of those, okay? So calculate the average rate of change for both functions over the following intervals, right? So for x between -2 and 3, you could also write this, right, in interval notation as -2, 3, couldn't you? Remember that, including the 2? Well, the first one's pretty easy, right? For f of x, if we do y equals 5x plus 7, right? This is linear. Its rate of change, its slope is always the same, is it not? Okay? So since it's linear, right, slope is always the same. And that, of course, is, what's the rate of change of this?
5.
5, right? But let's go ahead and use this function. Let's use that tool up here just to verify that, okay? Let's just verify that we get a rate of change of 5, okay, between -2 and 3. So we have to find what y is when x is 3, right? And then find what y is when x is -2. So let's plug those in here. Let's do f of 3, right? Would be 5 times 3 plus 7. 5 times 3 is 15, plus 7 is
22.
22. Yep, 22. Now let's find the other one, f of -2. So that would be 5 times -2, right? Plus 7.
Be -3.
-10 plus 7 is -3, okay? So now I have these two values here, right? And I pair them with these two on the bottom, okay? So let's find the average rate of change here. So we got to start with this, whoopsie daisy, something. This value minus that value, right? So our average rate of change would be 22 minus -3. So be very careful. Negative minus parentheses. Don't ever put minus together, okay? Divided by what? What are the two x values that go with those?
-2 and
Well, we're going to do 3
3
minus
minus parentheses -2.
-2. So that's 22 plus 3, which is 25, over 5 equals 5. Right? So we verified, right? We knew that was our slope because it's linear, and that never changes with a linear equation. Now let's see if we can squeeze in, let's squeeze in g of 3 down here and g of 2. So now let's do g of 3. And what was g? G is 2x squared plus 1. 2 times 3 squared plus 1. And that's 3 squared is 9. 2 times 9 is 18. Plus 1 is 19, right? Now let's do g of -2. That's going to be 2 times -2 squared plus 1. What's -2 squared?
4.
4 times 2 is 8, plus 1 is 9, right? So let's do its average rate of change. So we do 19 minus 9 over what minus what?
3 minus parentheses -2.
Yep, 3 minus -2. So that gives us 10 over 5, which is 2, the average rate of change of that function. Okay? Now they want us to do it. I better draw a little line here so don't get confused. Over this other interval, okay, from 1 to 5, right? So those are the x values, the domain values, right? So let's find f of 5, first of all. So that would be 5 times 5 plus 7. 25 plus 7 is? Good, 32. Okay. Now let's do f of 1. 5 times 1 plus 7, which is?
Mr. Hefner,
Yeah.
where are you getting the 7? Oh, from the
Up here,
final.
that's our function.
Oh, okay, I see.
Yep, I'm just plugging in those two x values so I can put it in the rate of change formula, okay? All right, so the rate of change would be 32 minus 12 over what minus what?
5 minus 1.
5 minus 1, right? That's 20 over 4, which is, hey, it's the same, isn't it? It's like it doesn't matter what interval we're on. For that linear equation, that rate of change is always the same. 5 and 5. Let's do the quadratic, g of x. So g of 5, hang on one second. All right, sorry about that. Mr. Miller had to harass me for a moment. So let's find g of 5. Would be 2 times 5 squared plus 1. So that's 25 times 2 is 50. So 51, right? And then g of 1, 2 times 1 squared is 1. So that would just be 3.
Yeah.
Okay? Let's find the average rate of change for this
51
quadratic.
minus 3.
Yep.
Divided by 5 minus 1.
Over 5 minus 1. So that's what? 48, right?
48 divided by 4,
And that
which
becomes
would be 12.
12. So you see with that quadratic, over different intervals, we have different rates of change. So a quadratic, the rate of change is always changing. Okay, so it's kind of like if we were to graph that thing, right? So let's say that's 1 and that's 5, right? So I think the graph kind of looks like this, maybe roughly just, okay? So that's the rate of change between here and here on the graph, okay? And the other one was from what? -2 to 3, like from over here. So if we were at -2, call that 3. The other rate of change went from here, right, to about here. Okay, so you see that the average rate of change for that quadratic in those different intervals will be different, but it'll always be the same for the linear, okay? Anybody have any questions on how to find average rate of change? That will be on your test, okay? So make sure if you're not sure to do it, ask away, okay? All right, let's move on to part B down here. So the average, I bet they're going to ask something we just discussed. I always do that. The average rate of change for F was the same for both 1 and 2, but not the same for G. Well, why is that? What do we know about y equals 5x plus 7?
As a linear equation.
Is linear, right? Which means it has a constant what?
Constant rate of change.
Rate of change. Not CK. Yeah. In other words, the slope is always 5. Slope is rate of change, okay? But g of x, the y equals 2x squared plus 1, is what kind of function?
It's a quadratic.
Right. So in other words, non-linear, right?
Non-linear equation.
Okay. What can we say about the rate of change for this one? The rate of change for this one is always what?
It's always changing.
Yes. It's always changing. Okay. By the way, like if you're driving in your car, you're going at a certain speed, right? A certain rate, miles per hour. Wouldn't that be a rate, like a slope? And it's constant, right? What happens if you change that rate of change, that miles per hour? What do we call that? Anybody know? Let's say you're doing 30 miles an hour. And that's a constant rate of change. And then suddenly you're doing 40 miles per hour. What did you do?
You added.
You accelerated, right?
Oh,
You changed your rate of change. Your rate of change was 30. You increased it to 40. You changed your rate of change. That's called acceleration. Okay? So a change in velocity, right, delta V, is called acceleration. Anyway, I digress into science and physics. Okay, does anyone have any questions on finding average rate of change?